teachers and students. I am Vince Mendoza from STEM 16, and today I am going to explain two topics in basic calculus. Just wait a second. There. So my first topic is about chain rule. The question given to me is f of x equals 10 raised to 1 minus x squared. So first we are going to write it, the d of dx of 10 raised to 1 minus x squared. And next we are going to use the chain rule, which is the given topic to me. So we are going to write it as equals ln of 10. So ln is the natural logarithm used in some cases in chain rule. So ln of 10 times 10 raised to 1 minus x squared times the derivative of 1 minus x squared. And next we are going to get the derivative of these two. So we are just going to rewrite this ln of 10 times 10 raised to 1 minus x squared times the derivative of 1 minus the derivative of x squared. And now we are going to get the derivative of these two. So again, ln of 10, I'm sorry for my marker, 1 minus x squared times derivative of 1 is 0 minus the derivative of x squared is 2x. So for the answer, we are just going to combine all of them. So we will have negative 2 ln of 10x times 10 raised to 1 minus x squared. So that is the derivative of f of x equals 10 raised to 1 minus x squared using the chain rule. So the next question given to me is about the optimization. Excuse me, I do not have a whiteboard marker to stick this into. So there, a farmer wants to fence an area of 1.5 million square feet in a rectangular field and then divide it in half with a fence parallel to one of the sides of the rectangle. How can he do this so as to minimize the cost of the fence? So to get a paper, first we are going to write what was given in the equation, which is the 1.5 million. So it is called constraint. Constraint. And it is the area of that field, which is a rectangle that can be length times width is the 1.5 million feet squared. Now we are going to visualize the field that is given in the equation. So let us draw a rectangle. Oh, my marker is dying. There, and this is the fence that is cut in parallel. So we are going to label these lines so that it will be easy for us to identify. So let's name this side A, side A, side B, B, B. There. So let us suppose that A is the width and B is the length. Okay, so next we are going to write what is the objective function. Objective function. And it is said that in the question a while ago, how can he do this as to minimize the cost of the fence? So to get the whole value of this field, we are just going to add everyone here. So f of b equals, so we have 3 b's here, so 3b plus 2a's, 2a. So that would be our objective function. So next we are going to derive this function and we will get the b first. So we are going to write, we are getting the derivative of that, the derived formula of this from here. So LW, so we are going to get the A first, the width. So LW, which is also BA because we substituted, equals 1.5 million per feet squared. So we are just going to divide it with L, so that it will be cancelled and we will have this. Next we are going to substitute this to the objective function. So let us write it down here. F of b equals 3b plus this 2a, because this would be our a. So 2 times 1.5, let's write it as 1 feet squared over b, which is our length. So next we are going to multiply it so it would be simplified. So f of b equals 3b plus 2 times 1.5 million feet square is 3 million. Feet squared, square feet over B. Then we are going to equate it to 0. So 0 no. We are going to get the derivative of this. So erase this. So first we are going to write it this. So the first derivative B equals 3B minus 3 million feet squared over B squared. There. That is the derivative of this function. So we are going to next, what we are going to do is we are going to equate it now to 0. So 0 equals 3B minus 3 million feet squared, square feet over B squared. Now, so for us to remove, we need to remove this denominator. So for us to remove it, we are going to multiply both sides by B squared, so that it would be cancelled, and we are going to have 0 equals 3B squared, because this would be cancelled too, minus 3 million square feet. Now we only have this, so we can now divide it with 3. So let's divide it with 3. It's timing. Cancel. We are now when we are going to have 0 minus 0 equals B squared minus 1 million feet squared. And now we are going to transpose this to the other side. So we would have a positive B squared equals positive 1 million feet squared. And we are going to get the B, which is our length. So we should square this to cancel this. So B would be equals in 1,000 feet. So that would be our length. Yes, our length. So next we are going to find our width. So if you remember a while ago, we made the derived formula from the constraint, which is, where is it? This. We can use this to get the width. So let's rewrite it again. A equals 1.5 million divided by B. So we already got the B. Now we are going to substitute this 1,000 feet. Let's write feet squared. We are going to substitute this 1,000 feet, which is the length here. So equals 1.5 million feet squared divided over 1,000 feet. Now we are going to get 1,500 feet. So now we have B 1,000 feet as a length and A with 1,500 feet. So let's go back to the diagram a while ago, the rectangle, the field. So let's draw it again. This is A, B, B, B. So if our B should be 1,000 feet and our A should be 1,500 feet. So, and it should be that way, it should have that measurement so that the farmer in the question, so the farmer would minimize the cost of the fence. So that is all, and this is the final answer. And thank you very much for listening.